Okay, friends, let's get started. Okay, in last lecture we were talking about on key events. Okay, so let us see first of all a program for that. In last lecture we had discussed that if I press W, it should go forward. If I press S, it should go backward. If I press A, it should go left hand side by degree of 10. Similarly, if I press D, then it should turn right with 10 degree. And if I press C, it should clear the screen. Okay. So let us see how. So first of all, if we say screen on key, we call the function move forward and the key is W. So move forward is very simple. Forward by 10 pixels. OK, similarly, when it is move backward, then it will be backward by 10 pixels. But in case of angle, if you want to turn left by 10 degree on pressing A, then we say new heading is equal to team.heading plus 10. So team.heading means whatever the current position is. OK, we add 10 and we'll set the new heading. OK, and set heading is equal to new heading. In the same way, on the right hand side means we have to reduce the 10 degree and we'll set that particular heading. OK, so let us run this. This was already discussed in last lecture. If I press W, it should go forward. Similarly, if I press S, it should go backward. Now, if I press A, it is moved by 10 degree. So I alternatively I press A and W. Every time it move and move forward. Okay. Now if I press D, it will be towards right. So D and W. Okay. So whatever we want, we can do here just by pressing the keys. Instead of this W, S, A, D, you can use arrow keys also by writing up, down, left and right. Okay, let us stop this. Or if we press C, okay, so it should clear all the paths covered by the turtle. Then if I don't write this, what happens? Let us see. Okay, say W and C. So it is, let me take say W and C. So it will clear all the paths covered by the turtle, but when it come back, it will draw a line. So we want this line not to be drawn. Okay, and that's why we use pan up. Okay, and then home is the function which will take the turtle to the original position. Okay, and after going to original position, again we have to pan down. Okay, so that next onwards by pressing W or S or A or D, we can draw the required path. Okay, so this is all about on key events. Okay, now we are going to discuss is the turtle racing. Okay, so let us do that. Okay, first program. So as you know, let me show how our aim is. So when we run this program, it will give us a pop-up which will ask me, see, I have given a title bet on race. Which color turtle will win the race? I guess if I say red, whatever color I want. And if I press OK, then the race will start. OK. So when any one of these reaches to the borderline, it should stop the process. OK. And the output should be that the winning turtle is blue. As I told, the red turtle will win the race. That's why I have lost the game. Okay, and so now let us see how to develop this game. Let us discuss one by one all the steps. So first of all, we have to create screen and the turtle. As usual, we know we can say from turtle and screen. Okay, we'll create object for these two class. Team is the name of the turtle I want. Turtle. Okay, as we know, the last statement should be screen dot exit on click. Okay, now next important is we cannot take the default screen size. What happens if we take default screen size, then we'll not be able to know the exact position of on a screen. Okay, so we want the screen to be of the fixed size. Okay, for that we can use the setup command for setting the size of the screen. For example, say screen dot setup. Then you can see this width is equal to something and height is equal to something. Okay, so if I write width is equal to say 500 and say height is equal to say 400. Now let us run this. So I can see now the screen with a specific size. Width is equal to 500 pixels and height is equal to 400 pixels. Okay, but we don't know the order of the variables, or we can say arguments, that which one is the first one. Okay, and so instead of using the positional argument, we will it will be better if we use the key argument. Okay, so we write here width is equal to 500 and say height is equal to 400. So now anytime whatever the order of the argument, as we have used the key word argument, width will be 500 and the height will be 400. Okay, so this will be the screen. Now next, now let us see the documentation that we want the pop-up where user can input. Okay, so on the screen, let us see how this is the document. As we know, here is some events for input methods, text input and num, I and put, num input. So if you want to input numeric values, we can use num input. And if you want to give text input, then we can select this text input. So if we select this text input, then see the documentation. There will be two arguments, title and prompt. Title means both are of string type. Okay, title will be the title, as we know that for our game, the title is supposed to say bet on race. Okay, and prompt is the message if we want to give for getting the input. Okay, so let us see how we can do this. Say screen dot text input. We can say bet on race. The message we want to give, say which turtle will win the race. Give color. Okay, now if we run this, we can see a pop-up on the screen where bet on race is the title and the message that which turtle will win the race, give color. Okay, so here suppose I give say red color, and if I press OK, right? So in this way we can give color our choice. Okay, but this is to be whatever the input we give, that is suppose I have given the red color, so that is to be stored somewhere, right? So we can say user choice or say user bet is equal to this. So now if we try to print a user bet, then whatever the input will be printed on the console. Okay, let us see if we run this, say red, then you can see on console red is printed. Okay, so user bet is the variable which contains the user choice. Okay, now next we want store the user input, create a single turtle with its proper position. Okay, so now we want to create the turtle. So let me take this below this. Okay, so I'm creating the turtle. Okay, so initially I have created team as a turtle. Okay, now if I want it should be at a particular position. So first of all, before checking it the original position, first of all let us give it shape. So here we, as we know, that team dot shape is equal to say turtle. Right, so if we run this, say red. Okay, so we first of all created the turtle. And at the same time, its shape should be, oh, it should not be like this. Okay. So here we can see this is the turtle. Okay. Now here, let me give you one information that any turtle, it may be a circle, it may be a square, or it may be an arrow. It will be in the 40 by 40 pixels. Okay. So the size of the turtle will be 40 by 40 pixels. Okay. Now if we move the turtle, okay, so first of all, we have to take the turtle to a starting position for the race. Okay, so we cannot go simply back and get its position because we want more than one turtles with different positions. So let us understand the coordinating systems of the turtle screen. Okay, let us see that I have created a small presentation with one slide to show you. OK, so our screen is considered as a graph. OK, initially our turtle will be in the center. That will be considered as position 0, 0. So initially our turtle will be at the center. OK, now as we know, our screen is of the size 500 by 400, or we can say height is 400. So height of our screen is 400. So on the y-axis, the coordinate will be from 0 to 200 on upper side, that is positive side, and from 0 to minus 200 on negative side. So actual 400 pixels will be from minus 200 to plus 200. Okay, and similarly our x-axis, that is width is 500 pixels, So our x-axis, it will start from 0 to 250 on the right hand side, that is positive side. And on the left hand side it is from 0 to minus 250, that is on the left hand side. Okay. So for example, suppose I want any turtle to be here at the middle of this, that is middle of x and middle of y, somewhere here. So middle of x means x should be 125 between 0 to 255. Okay. And y will be 100. So this position is x coordinate is 150, 125 and y coordinate is 100. But we want actually to start from this particular position. Okay. For example, this. So this may around say our y, our y will be say, let me take say 170 approximately. And say our x will be say 230. If I take 250, it will reach to the border line. Okay, so half of my cursor will be outside the border line. So let me take it at about 230. Okay, so this will be position say 230 and 170. So similarly, we want all 6 turtles to be started from the same line. So same lines means x distance will be same for all the turtles, but the y coordinate will be differ. Okay. For example, these are the 6 turtles. So their y coordinate will be differ. X will be the same. Okay. So we can say that x is minus 230 fixed and the y is varying at some equal amount. Okay. So now let us go to our program part. Okay. So we want to take our turtle to a particular position, and for that we have go to command. Okay, so we can say team dot go to say x is equal to say minus 170 as we have discussed, and say y is equal to say minus 0. Now if you run this, say read, so our turtle is going out because we have returned the coordinates x value as y and y value as x. So x should be 230 and y should be 170, right? Okay. So now you can see the turtle is at proper position, but we are getting this line. It should not be there. So we simply use pan up. Okay. Set team dot pan up. Okay. Now if we run this, then we can see the turtle at a particular position. Now we want 6 such turtles. Okay. Can you do this? You simply repeat this for 6 times. For example, if I repeat, say for dash in range 6. Okay, and if I repeat, I will get 6 turtles, but all will be at its same position. Okay, now I want this y to be changed every time with a fixed distance, say 30 or 40 pixels. Okay, can you do this? Okay, you just set the y coordinate by incrementing 40 pixels. You do it and write your code in the box. Okay, or let me keep it on. Okay, you can see this code also. Just do it by changing the y coordinate. These lines you can copy, simple, these 4-5 lines. Okay, and just we want to change this y. Every time it should be incremented by 40 pixels. Okay, so initially we can take, say, let us see y coordinate is equal to, say, minus 170. Here we can say new y is equal to y coordinate plus 40. Let us take as, say, y coordinate. Okay, now you can change your y coordinate by adding. Okay, so if we run this, okay, we are getting 6 turtles here at some equal distance. But if we want it in the middle, so we can take the first turtle little higher. Say, let me take it at, say, 120. Okay, let us run this. Okay, still if you want to take higher. Okay, so we got the 6 turtles. Okay, at their starting positions. But all the 6 turtles are of the same color. So we want all the 6 turtles of the different colors. Okay, so what I can do, I can take a list of colors. A red, a green, a yellow, a blue, purple. Okay, so now instead of taking a particular color, we can take a color from the list. So originally, as we did not assign any color, it was of black color. Okay, now doing this, let me take a turtle index. And set team.color into bracket colors, and the variable is turtle index. Now if we run this, we can see all the 6 turtles will be of different colors. Okay. Okay. So we got all the 6 turtles at proper starting position as we want. Right now, we want all the turtles to move forward with some random distance. Okay, we want say forward. I say random distance between say 0 to 10 pixels. Okay, so for that we need to have a random function. Okay, so we can say import random. We can use randint because we want integer between 0 to 10. So we can say random dot randint. Okay, so we can make the turtle forward with some random distance, right? Or say team is my turtle. But what happens? We have 6 turtles. Okay, so we don't know now which turtle will be moved. We want all the 6 turtles to go forward with random distance. So we have to identify all the 6 turtles differently. Okay, so for that, one option is we can create a list of the turtles, say all turtles is equal to say blank list, and we append all the turtles here in the list. Okay, so as and when the turtles created, at the end we can do this thing, no problem. They're all turtles dot append into bracket turtle team. Okay, but see, just team will work, no problem. But the team is a name of a particular turtle. We want every time different turtles. OK, so just to understand, team will also work. So I want to give another name. So OK, so let me refactor the name, refactor, rename. Let me give a new turtle. Refactor. So all this team is replaced by new turtle. See, as far as the variable is concerned, both will work, but just on reading, we can understand that this is a new turtle created and we are going to append in the list. OK, so all turtle is a list. OK, where all the 6 turtles are appended. OK, now we want to continue racing for all the turtles. That means we have to continue till a particular value becomes true or false. OK, so let me take one variable called say is race on equal to say false. Okay. And when user give their color for betting, then we will say if user bet is equal to true, then we can say is race on is equal to true. OK, so we will repeat these things, right? So while race is on, we'll repeat. What we'll repeat? We'll run all the turtles randomly. OK, so for running the turtles, we take the loop. Say for turtle all the turtles, sorry. So now I want turtle to go forward. by distance 10 randomly. Okay, let us see what happens. Okay, so all turtles started moving, right? Okay, but even we have not applied any stopping condition. So all the turtles will continuously go on running, go on running. When it will go beyond the screen or right edge, there will be error. Okay, so we have to have some stopping condition. So now let us recall that our graph paper. Okay, this one. So the rightmost line is 250. And as I told you that my turtle is of say 40 by 40. For example, this say it is 40 by 40. So when it reaches to touch to the line, okay, so this line will be at 210. But let us take half of this. Okay, that means only 20 pixels before this. So when it will be, when any turtle reaches beyond the 230, we'll stop the game. Okay, so what we will do, we will check whether moving it forward, we should check if turtle right hand side means x-axis towards positive, right? Okay, so we can check if turtle dot x coordinate greater than 230. Then what we have to do? We have to stop. Okay, stop means race is on is equal to false. Is race on equal to false. Else we have to continue. Okay. Okay, let us run. Okay, so it stops, right? Now, when it stops, what should be the output? Okay, so when we make it false, when it is reaching to a particular position, we should know that which color turtle is winning. Okay, which color turtle reaches to the boundary point. Okay, so for that, we have to find out the color of the turtle, present turtle, which reaches beyond the 230. So here we can know that turtle dot color. So if we use this function, it will return the turtle color. But let us see the document. Say color. Okay, so it will return two values, pen color and the fill color. You can see here, pen color and fill color. Okay, so we'll not be able to find out that which color we want. At some places it may be different also. So better if we use a pen color only, so it will return only one color. So we can take a pen color. Okay, so this color we have to store somewhere. So winning color equal to say turtle pen color, right? Now if we check if winning color is equal to which one is the user color, user choice, it is user bet. Okay, it is equal to user bet, then we'll print the message that you win I have to take F string because I want the value of the color. You win. The winning turtle is of this color. Okay, which color? This is the winning turtle. So this message, if it is not true, okay, so we can say else. Same message, but you will lose. You have lost the game, but the winning turtle will be the same. Okay, now let us run. Oh, sorry. You can see you have lost. The winning turtle is of orange color. You can see this is the orange color turtle. On bet, I have given the red color. OK, so this is as answer is as required. OK, so this is all about the turtle racing game. OK, madam. Hello, madam. OK, friends, we have completed our workshop. Actually, there are lots of things in the Python. Whatever the things we have covered, we can say it is even less than 10%, right? So if you are interested, you can go further. You can ask even in future, whichever the portion which is not covered in the workshop also, for that even you can ask me. I have told the organizer, means your teacher, to open up the session so that if you have any difficulty or if you want to ask anything, you can ask me, or even you can give me the feedback that whether it is fruitful or not. OK, there will also be a written feedback, but if you will give feedback to me so that I will be able to improve myself, right, for the next time. OK, so I have told them they will open the session, and if you have any suggestion, feel free to say. OK, thank you very much.
Okay, sir. Sir, they can unmute themselves now.
OK, so any of you, if you want to say something, you can unmute and you can say, particularly if you want to give any suggestion, so please give so that I can improve myself for the next session.
Okay, students, you can unmute yourself.
Okay, so let us stop. You can give it when they are asking for the feedback. Okay, so thank you very much. You learned patiently and give me a chance to give you something about this Python. Thank you very much, everyone. Okay, and also thanks for organizing this workshop to all the VSITR principal and all the faculty members. Thank you very
Thank
much.
you so much, sir. Thank you, sir.